Hello and welcome to this video. We are going to solve the exercise, Exploiting Exact Match Cache Rules for Web Cache Deception. In the video description you will find a link to a write-up. The write-up contains more detailed descriptions. So if you have any questions, just have a look in the write-up. After we have started the exercise, the blog should look similar to this in the video. We click on the link, My Account, and log into the application with the username Wiener and the password Peter. Normally there should be no email address in Wiener's account, but the lab has been started before. We now see our account and change our email address to wiener2@hacker.de. We now switch to the Burp proxy and open the HTTP History tab. In the HTTP history, we search for the request get/myaccount and see a CSRF token as a hidden parameter in the response. We send the request get/myaccount to the Burp repeater. In Burp repeater, we append the character string ABC to the path/myaccount. We now send this request to the application and receive a 404 not found. This means that the origin server does not abstract the path to /myaccount. We now change the path to /myaccount app and send the request to the application again. The response is again a 404 not found and contains no indication of caching. We now send this request to Burp Intruder. Switch to the Burp Intruder and adjust our request so that we can identify limiters. First, we make sure that Sniper Attack is selected as the attack method. Then we click with the mouse in the path/myaccount tab between /myaccount and ABC and press the button Add. We now go to the start page of the exercise. There you will find a list of limiters. This list is also in the write-up. We copy this list and click on the Paste button in the Payload Configuration subsection of the Burp Intruder. In the subsection Payload Encoding, we deactivate the checkbox URL encode these characters. Click on the Start Attack button to start the attack. In the result window, we now click twice on the status code column and see that the characters semicolon and question mark have received a 200 OK code. Now we go to the Burp repeater and test our two delimiters semicolon and question mark. We adjust the path/myaccount app as follows. When we send the request, we get a 200 OK but no indication of caching. We now replace the character semicolon in the path with question mark. We receive a 200 OK, but again without any indication of caching. In the repeater, we now remove the character string abc.js from the request and insert a directory with an attached coded point sequence /AAA/%2fmy account. We receive a 404 not found in response. This indicates that the origin server is not decoding or resolving the dot segment to normalize the path to /myaccount. Now we switch to the HTTP History tab in the Burp proxy and see that static files all start with the prefix /resources. We now change our path to /robots.txt and send it to the application. We now receive a response with the headers cache control, age and xcache with the value miss. If we send the request to the application again within 30 seconds, the value of the header is xcache is hit. We now place the coded .sequence in front of /robots.txt. We receive a 200 OK response. This shows that the cache is normalizing the path to /robots.txt. We now construct the following path with the delimiter question mark and send it to the application. We receive a 200 OK response, but no indication of caching. We change the delimiter to semicolon and send the request to the application again. We now receive a response with the headers cache control, age, and xcache with the value miss. If we send the request to the application again within 30 seconds, the value of the header is hit. Now we switch to the exploit server by clicking on the button in the browser. In the exploit server, we scroll down to the body section and insert the following exploit code there. This code redirects the victim Carlos to a malicious URL. At the end, we insert an arbitrary value as a cache buster, WCD, so that Carlos does not receive the previously cached response. Click on the Deliver Exploit to Victim. We then copy the URL from the exploit and paste it into a new tab in the browser. We see that the browser redirects to the login page. The exploit may have to be delivered to the victim several times before access to the login page is possible. We now switch to the Burp repeater and change the path of our request from robots.txt to robots.txt WCD. We click the Deliver Exploit to Victim button again in the exploit server and send the request in the Burp repeater within 30 seconds, twice in succession to the application, and see that the header xcache contains the value hit. If we scroll down in the response, we see a CSRF token there. We switch to the HTTP history in the Burp proxy and search for the request post/myaccount/change email. We send this request to Burp repeater. In the repeater, we replace the existing CSRF token with our CSRF token that we have just captured and change the mail address to a new address that we have not yet used. Now we move the mouse over the request and press the right mouse button. A context menu appears in which we select the option Engagement Tools. Another window opens in which we select the option Generate CSRF POC. The CSRF POC generator window now opens, in which we click on the Copy HTML button. We now add this code to our exploit server in the Body section and click on the Deliver Exploit to Victim button. The exercise was successfully completed.